Hello, this is James, and let me introduce myself at the board over there, right? So let's go to the board. All right, my name is James Yu. James Harim Yu. So you could definitely know my Korean name, right? But you know, that's irrelevant, I guess. But just listening to this name or looking at me right now, you are the lucky one. So you are pretty lucky to see me teaching this course, I guess. So this course is math course, right? APBC, especially for single variable integral calculus, right? And well, I think I have to continue my introduction, right? So I actually attend this Northwestern University in Evanston University. And I am a math major, right? Math major. And also one important thing is that in my sophomore year, I became class assistant. So it's called class CA, and it's unofficial. It's only for invited one, I guess, by the professor. So this is my unique experience, I guess, because I went to the classroom every time whenever professor has a class, and I went there, and if anyone raises his hand, I have to go there and answer his question immediately. And you know, I didn't only teach this type of single variable calculus. I taught multivariable calculus as well. So I was doing more than the ordinary teaching assistant. And then I became TA because now I am kind of eligible to become TA because you can become a TA at your junior year because you should have learned, well, you wouldn't really have to learn real analysis and abstract algebra in order to become TA because I beat them all among like 34 people in competition. So using that experience, it's lucky for you to have me as a teacher because 5 out of 5, right? 5 out of 5 is nothing. It's nothing if you listen to this lecture. So be sure to notice 5 out of 5, it is kind of like borderline. It's just like ordinary condition for you. So it's not even prerequisite. If you do well, at least if you see this lecture, listen to this lecture, and study yourself for at least 30 minutes a day, 5 out of 5, it's easy, right? That's not my goal. It's just like something that you would get immediately after listening to this lecture. Why? Because, well, let me go back to the first semester, not semester, but first quarter of Northwestern University at sophomore year. Well, it wasn't first quarter. My professor actually asked me, kind of requested me to join her class at her second quarter. And at the second quarter, I taught single variable integral calculus, right? Integral calculus. So this is it. Integral calculus is the thing that I'm going to talk about in this lecture. Because APBC, well, usually it's integral calculus for single variable. And at the same time, you have some kind of, deeper, some kind of harder concept. But it's not really hard. You wouldn't really have to worry about being hard because those concepts that are harder than this is just like vector calculus for multivariable, right? Especially for differential calculus. And some kind of linear algebra, elementary row reduction. Well, you would see those things at the very end of my conceptual lectures. And after that, I'm going to get into some applications of those problems in real AP tests so that you could see the connection between concept and the real application as a test question. Now, integral calculus, I taught this course. And unlike ordinary TA, because I was very unique case, it was really unique case, I guess. I even held a lot of like review sessions, right? Review sessions and, review sessions first. And attendance every time. Attending the class every time. So TA doesn't really come to this, the real class. because they opened up something called discussion session. Now, unlike discussion session, I always attended class session. And at the class session when my professor, well, Professor someone, well, let me use her name then. Professor Bode was using some kind of, like her PDF files or kind of showing you which type of algorithm you have to use. If someone raises his hand, I have to go there and answer his question. Now, that was my key. So that's why whenever I held an office hour, people always came to ask me a question. Now, with this, I taught 300 people, students, every quarter. And I have those as 2 quarters, right? 2 quarters. That means I had an experience at least for 600 people. Now I'm having more experiences with you, whom I can't see right now, but you would be one of my valuable experience. So I hope you enjoy all of those lectures. So this is an intro, right? Intro to this integral calculus. And as I said before, well, I haven't said this before, right? But I have said this in Korean lecture, in a Korean version, but I'm not going to focus on differential calculus in this lecture series. Because differential calculus, I'm going to use another lecture series so that you could take that part and delve into it. Because integral calculus, well, let's first look at what calculus is, right? What is calculus? Right, calculus. Calculus can be divided into 2 parts, differential calculus and integral calculus. Right? Differential and integral calculus. Why? I don't know. Well, okay, so I haven't said this in Korean lecture, but let me show you why this has been divided into 2. Well, it started from 2 branches, right? Then it was connected. That's the key point. Out of around 1660s, I'm gonna talk about this later on this lecture 1. But around 1660s, one person found out that there is a connection between differential calculus and integral calculus. It's like inverse of something. So f and g, well, we found a function, and actually this processes, well, if we call this each process as function and function, well, f inverse is actually g. And that is the thing. And it's not necessary for you to understand what this means, but as you have learned in SAT 2, you must have known this at least, right? What is inverse? It's one-to-one bijection. Well, bijection, you wouldn't really know what it means, so I'm going to skip over that part. But differential calculus and integral calculus, why am I teaching you only integral calculus? Well, integral calculus and differential calculus are different in essence. Because differential calculus, differential calculus is talking about differential, right? Differential calculus talks about the study of change. Well, calculus is study of change, but this is a study of slope, the rate of change. So whenever you see when slope is changing, you call that f prime is actually increasing, right? You're saying those type of things. Right? But integral calculus, we're not doing that. We're approximating. We're getting the values. We're getting the values of area, the volumes of something. So, integral calculus is the study of volume and area. Now, what does that mean? Well, it means that you have some values, right? Some area, geometry. So, integral calculus is more relevant to the geometry, but differential calculus is more relevant to algebra. Well, not necessarily, but calculus is a different branch from algebra and